to see you here again. This is another video offered to you by the Ceuster Academy. In this video I'm going to talk about the present value of a series of cash flows. But before we start, do not forget to click on the subscribe button, click on the bell button so every time we publish a new video, YouTube will inform you. Now, in the previous videos we looked at the simple interest, the compound interest, we looked at the future value of a single cash flow, the future value of a series of cash flows, which gives us, let's say, an idea when we put every year, every period money to the side, how much these cash flows will be worth after a certain period. It's very interesting when you want to do a saving, you can do those calculations and you can find a way, for example, to save for future projects. And that's typically also what companies are doing. They're putting money aside for future projects. Now, on the other hand, we also have the present value. In the previous video we looked at the present value of a single cash flow, and we wanted to know when we get money, for example 10 years from now, what is that money worth today? We call that basically discounting. Now we're going to do the same thing. We want to know the present value of a series of cash flows. So basically we are expecting a series of cash flow in the future. When we want to do calculations today, we have to have an understanding how much these cash flows will be worth today. So this is discounting of those cash flows, and there are two possibilities, typically two possibilities that exist. We have basically two cases like we had in the previous video. First, we have the case where all cash flows are basically identical. So every year we have the same cash flow. It can be done when we are looking at some provisioning, some idea about future projects and so on. Basically, it gives us an idea when we have constant cash flows, what the present value of those constant cash flows or identical cash flows will be today. In reality, it may be different. We may have different cash flows depending on the real situation. And when we want to compare the real results, or when we have more realistic approaches, we may have a series of cash flows that vary from year to year. And then we have a different approach. But first, let's have a look at the identical cash flows. And the identical cash flows, they are considered to be at the end of the period. Now, when we look at this table here, we have in fact 5 cash flows, 5 years. And now we have to see what are these cash flows worth today. I have in year 1 up to year 5 the identical cash flow of $2,000. Now, first thing we have to do, we had a discount rate of 7%. So now we can, in fact, calculate the discount factors. And the discount factor is given by 1 plus the interest rate to the power of n. So for the first year, that will be, in this case, 1.07 to the power 1, or minus 1 is in fact 0.9364. And we always have 1 plus the interest rate to the negative power of the number of years. For the second year, we have 1.07 to the power of negative 2, which gives us 0.8734. For the third year, we have the discount rate of 1.07 to the power negative 3, which is 8163. And for the fifth year, we have 1.07 to the power minus 5, which gives us 0.74. or 130, I'm sorry. So basically when we multiply those numbers with the original amount, we see that for year 1 we find $2,000 multiplied with a discount rate 0.9364, which gives us approximately $1,869. I don't mention the decimals, but they are there on the board for completeness. When we look at a third year, we see that we have to multiply with a discount factor 0.8163, and we find $1,632 and some cents. So we do that for all these cash flows, and we add them. So the total present value of all those cash flows is the sum of those present values, and this is equal to $8,200.94. Now, like we had in the previous videos, we could use a predefined formula which is available in Excel. And when we look at that formula, the formula is the present value, where we have the rate, 7%, the number of periods, in this case 5 periods, the periodic payments, minus 2,000, it's 2,000, but we have to put there minus 2,000 to get a positive outcome. Present value or future value in this case is equal to 0, and the type is 0. We consider the payments at the end of the period. And we find again, when we apply this in Excel, $8,200.94. On the other hand, when we have variable cash flows, the story is a little bit different. We cannot use the formula that we have in Excel, because every period the cash flow is changing. For period 1 now we have $150, for period 2 $300, for period 3 $425, for period 4 you see $500, and for period 5 $150. Now the discount factors are the same, because we use the same percentage, and we can reuse those discount factors to do the calculations. So for the first period, the $150, I multiply with 0.9364, and I find $140.46. For the period 3, I have the $300 multiplied with the discount factor 0.8734, which gives me $262.02 in fact. We do the same for $425, where we find $346.93, for $500 in the fourth period, where we get $381.45, and finally for the fifth period, the $150, their present value is only $106.95. The same thing to find the present value of all these cash flows is basically that we take the sum of all of them, and we find that the present value of all these cash flows is equal to $1,237.81. Now, why is present value so important? Well, consider what you're going to do. You're going to invest in a project. And basically you have a certain amount you invest, that's your cost for the project. And you want to compensate that cost by sales, by cash flows, positive cash flows in the future. So you want to make money, so you want to know, you want to compare what your investment today was with the value of those future cash flows. And that's why you're going to discount these amounts, and you're going to find what is the present value of all the revenue you're getting, and you're going to compare it with the initial investment. Is the present value of all those future cash flows larger than your initial investment? Then you can say that you have a profit. On the other hand, when the amount would be less than the initial investment, then you would be at a loss. Another application would be like a mortgage. When you lend a house, you lend money which is the present value to them. And you're going to pay over the future, you're going to pay a certain amount, a monthly amount, to compensate for the loan. Basically what you're going to do is you are paying back your loan with future cash flows. So what the bank wants to know, when you have a certain interest rate that has been agreed, you have to see that the future cash flows, that their present value is basically equal to the value, the present value of the house. And that's how they calculate the mortgage with fixed payments. So there are different ways that we can do that. We will look at some other possibilities, but basically that's the reason why we have to understand present and future value. What are we getting from the future cash flows? And when we are putting money to the side, how much money will we have after a certain time frame if we want to save for something? Now that was it for this video, but before stopping the video, do not forget to click on the subscribe button, click on the bell button, so every time we have a new video, YouTube will inform you about it. I thank you very much, and I'm looking forward to seeing you in one of our next videos. Bye bye.